Hello friends, this video on acid and base part 4 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 3. Now we'll study salt. What is salt? Salt is nothing but ionic compounds that is formed from neutralization reaction of acid and base. So you take acid and base, you do a neutralization reaction. I'll tell you how. I think you have learned in the past chapter what is neutralization reaction. You have acid plus base. It gives salt plus water. Right? This reaction we have done. The salt is something which you get from neutralization reaction of acid and base, and they have cations and anions. If you see, we'll take an example. The positive charge and negatively charged ion they have, and they are electrically neutral. Please note, the salts are generally neutral with no charge. There is no charge on the salt. Example in this case, if you see HCl plus NaOH is equal to NaCl plus H2. This is a very common reaction. So if you see in this case, the convention is always we see acid plus base, right? So the first guy is generally acid. And we know also that HCl is acid, so this guy is acid. NH is we know is a base. So you add acid and base, you get salt plus water, right? So this guy is the salt and this guy is the water. So if you see the reaction, what happened here is you have H plus Cl minus, you have Na plus OH minus. So in this case, if you see that you got Na plus Cl minus and H2. So what happened here is, since this guy was acid HCl, it will give a hydrogen ion to this guy. Since this guy is a base, it will accept the hydrogen ion. So this H and OH minus will combine to form a water molecule. Similarly, now we'll have Na plus and Cl minus floating around, right? They are all free now, so that will become NaCl. And they have an ionic bond. We'll explain why its ionic bond is. They have an ionic bond between them. They're all free actually. And in the aqueous solution, if you put this NaCl, you get Na plus ion and Cl minus ion separately, and they'll float around. They'll float around like this. If you have to put this in water, so if you put this in water, you'll find a lot of Na plus ion and equal number of Cl minus ion. So that's what happened. We'll explain this part later, but what I'm trying to say is we have HCl which has excess of hydrogen and the acid, so it will give the acid, and we have NaOH which will accept that H plus ion. So OH minus and H plus will give you water, and sodium and chlorine will be there, and since they'll form ionic bond and they're all stable. We'll explain how this works, but this is a reaction, and salt is something which is formed from the neutralization reaction of acid and base. Why study salt is a very obvious question. We know the most common salt is the common salt which you use, right? Common salt, NaCl, and it has a wide application. When you are cooking, we need common salt. We use this common salt for preservatives, right? There are a hell lot of application for common salt. If, for example, this guy, from this guy, you get bleaching powder, then you get, I think, a lot of stuff you get. Sodium hydroxide you get chlorine gas. These are all the byproducts of common salt. So from common salt, you do something and you get all these things. We'll explain all this part, but yeah, in industry use, we can get all these things from common salt. And common salt, a lot of places it is used, common salt. So common salt is, we all know what is common salt is, and that has a very critical application in life, and that is one of the reasons why we should study salt. Now, what can be the color of salt? Whether salt blue, black, white? So let's see this. Salt can exist in different colors. Example, sodium chromate is a salt that is yellow in color. Potassium dichromate is orange in color. Potassium ferricyanide is red in color. Cobalt chloride hexahydrate is mauve in color. My copper sulfate and ferric hexacanoferrite is blue in color. My potassium permanganate is purple in color. My nickel chloride hexafluoride is green. Sodium chloride, the common salt, is white in color, we know this. And you have manganese sulfate heptahydride, is colorless. So if you don't remember this name, it's okay. The point was that the salt exists in many colors. That's the only point we should derive from the slide is, so we have salt and it exists in many colors. So it can be yellow, it can be orange, it can be red, it can be blue, purple, green, white, colorless. It can be any color. So there are many colors of the salt. But it's good to know something. For example, ferric copper sulfate pentahydride, potassium permanganate. It's good to know the color of this because we use this a lot of time. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.